Good day, viewers. In this video tutorial, I'm going to teach you application of differentiation. Where to apply differentiation. Let us look at the question. Said the rate of working of an engine is given by the equation P equals to 2V plus 1800 over V, where V is the speed of the engine. Find the speed of which the rate of working is least. Find the what? Find the speed of which the rate of working is what? Least. That's the question. Then now let us go into solution. But remember, before we go into solution, like this channel, share this channel, and subscribe to enable me grow my channel. Your subscription is very necessary to me. That's an encouragement to me. Thank you for doing that. Let's go to solution. Then now, looking at the solution, what does it mean? They said we should find the speed of which the rate of the working of the engine is what? Least. So the rate of working of the engine to be least mean at minimum. We are looking the value of what? Velocity or speed at which the rate of what? Working. The rate of what? The engine working is at least. Mean we should find the velocity at which the rate is at what? Minimum. Then when I say, you remember, at minimum, we remember that at minimum point or maximum point, at minimum point or maximum point, when we say minimum point, look at the maximum point, look at the curve, look at the maximum point, then look at this, look at the minimum point. At any of these points, we have that what? Dy dx is equals to what? 0. At minimum what? At what? At minimum point or maximum point, dy dx is equals to what? 0. Then since we know this, that dy dx at minimum point is equals to what? 0, we now start from looking at the equation given us. That's at what? Minimum or maximum point. Then now look at it. At minimum point or maximum point, we have this. And remember, the value we get at minimum point or maximum point, the value we get at that point is called critical point or critical value. We say at the value we get at minimum point or maximum point is called what? Critical value of that what? Point. Then looking at this, I have my P to be equals to what? 2V plus 1800 over V, which simply can be written as 2V plus 1800 into 1 over V. I think we can write it this way. And this simply means that P is equals to what? 2V plus 1800 into what? V minus 1. You know that this 1 over V can be written as V raised to the power minus 1 in indices. Then now, I'm going to differentiate P in respect to velocity, speed. I will now say dP dV is equals to d2V plus 1800 V minus 1 all over dV. And this can be written as, differentiating them separate, I'm going to have d2V in respect to dV plus d1800V minus 1 in respect to what? dV. Then what is next? I'm going to have that this I write here can be written, looking at this is a what? Constant. This is a constant, this is a variable. Since this constant is attached to variable, I can bring it out. I'm going to have d 2dv all over dv. I have bring the constant out. This is attached to what? Variable. So you survive the differentiation. Plus, this man is a constant. Oh, what did I write here? That should be what? 1800 v raised to power minus 1. Then now, this 1800 is a constant and is attached to the variable which is v raised to power minus 1. I can bring it out to have 1800 dv raised to power minus 1 all over dv. Then now, the next thing, dv will give me 1. Differentiating the velocity in respect to velocity will give me 1. Differentiating this will give me 1800 into, differentiating this will give me minus v raised to power minus 2. If I differentiate this, differentiating this means I'm going to subtract 1 from the power. I will use the power, look at it, I will use the power to, which is power is minus 1 to multiply v, then subtract 1 from the power. I will use this power minus 1 to multiply v, give me minus v, subtract 1 from the power, give me minus 2. Then doing this, I will have 2 plus, this man is same thing as 1800. This can be written as minus 1 all over what? V raised to power 2. This can be written this way. Then now, doing this, I'm going to have that this become 2 minus 1800 all over what? V raised to power 2. Are you following me now? Then this can be written, this man, remember that at critical point, at minimum, or maximum points, what do we have? We have that dp dv is equals to 0. dp dv is equals to what? 0. At minimum point, we have that what? 2 minus 1800 over v squared is equals to what? 0. Then now, making this subject of formula, I'm going to have that what? 2 is equals to 1800 over v squared. Taking this over here. Then I'm going to do, this is over 1, cross multiplication. I'm going to have that 2v squared is equals to what? 1800. Then v squared is equals to 1800 divided by 2. Divide through by 2. I will have this. Then I'm going to have that v is equals to square root of what? 900. This divided by 2 will give me 900. This divide 18 divided by 2, 900, that's 900. Then square root of 900 will give me v is equals to what? Plus or minus 30. Plus or minus what? 30. That imply that the value of v is equals to what? 30 or that's 30 or minus what? 30. 30 or minus 30. And this value of v is what we'll call critical value. Critical value, that's the value at minimum or what? Maximum point. We'll call it what? Critical value, which is what? The critical value is 2 in number. Since this critical value is 2 in number, we are going to use what we call second derivative text. We have how many texts? We have first derivative text and second derivative text. If this critical angle is only one value, if this critical angle become only one value that I have as my critical value, I'm going to use single, what we call first derivative test. I'm going to use first derivative test. But since it's not only one value, it has two values. Look at 30 or what? Minus 30. That means I'm going to use what? Second derivative test. I think I made myself clear. I'm using second derivative test on this man to test the nature of this velocity. I'm going to take the nature of the velocity to know when it is what? At minimum, or when it is what? At maximum. Are you getting what I'm saying now? So I have gotten the critical value of velocity, but I'm going to test the nature of the velocity by using the text which we call second derivative test. And why did I use second derivative test? Because I have a critical value of 2. I got a critical value of 2. That's why I'm using second derivative test. Assuming that I have a critical value to be what? 1, I'm going to use first derivative test. Then let's see second derivative test. Second derivative test. Second derivative test. The value at which second derivative of y in respect to x is less than 0. The value of that critical point at the second derivative of y in respect to x is less than 0. That value is what? Maximum value. We say is what? Maximum value. Second condition. The value at which the second derivative of y in respect to x is greater than 0. That critical value at that point is minimum value. The critical point at that point is minimum value. The critical point at this point is maximum value. Then coming to the third conclusion, we said the value at which the second derivative of y in respect to x squared is equal to what? 0. It implies no conclusion. It implies there's no conclusion in the nature of that what? The value. So let us look at it. We have differentiate the p in respect to v before. We have differentiate the p in respect to v, and we have 2 minus 1800 over v squared. That's what we have as first derivative of what? P in respect to v. That's our first derivative of p in respect to what? V. Before we now said at minimum or maximum point, this man p in respect to v become equals to 0. We now begin to resolve to get the critical value. So look at our first derivative of p in respect to v. dp over dv equals to 2 minus 1800 over v squared, which can be written as 2 minus 1800 over what? Into what? 1 over v squared, and this can be written as 2 minus 1800 v minus 2. That's what we have. That means that my dp dv is equal to this. Then I'm going to look for second derivative of this man. Second derivative of this man become d squared p all over dv squared, and which can be written as what? D all over dv into dv all over dp all over what? dv. That's what we're going to have here. And now, putting it over here, I'm going to have that this is equals to d 2 minus 1800 v minus 2 all over dv. Then I'm going to have this is going to be equals to what? d2 all over dv. Are you following me? Then minus d 1800 v minus 2 all over dv. And this can be written as d2 all over dv minus 1800 dv minus 2 all over dv. This is 1800, there's a mistake here, 1800 v minus 2. Then now this can be done in this way by saying differentiating 2 in respect to v is equals to 0. Differentiating 2 in respect to v is 0. Then minus 1800 differentiating v raised to power minus 2. Come over here. Differentiating v raised to power minus 2, it will give me times minus v raised to power minus 3. What do I have here? This minus 2 will come over here to times, I'm going to have minus 2 times v. Differentiating this man will give me minus 2 times v minus 3. Minus these 2 times v minus 3. That's, I mean, if I use this minus 2 to times v, I minus 1 from it. That's differentiation. Minus 2 minus 1 will give me minus 3. Minus 1800 times minus 2 will give me, what is going to give me will be 3600 v raised to power minus 3. And this can be written as equals to 3600. It can be written as 3600 v 1 over 1300 times 1 over v raised to power 3. This can be written like this. And this will be equals to 3600 over v raised to power 3. You see, this minus 1800 times minus 2 will give me 3600 v raised to power minus 3. And this v raised to power minus 3 can be written as 1 over v raised to power 3. Then this times the numerator will give me this. So what does it imply? Let us complete it here. What it implies is that my dv by d squared p over dv is equals to what? 3600 over v raised to power 3. D raised to power 3 p over dv equals to 3600 over v raised to power 3. Then, and I said d squared p all over dv equals to 3600 over v raised to power 3. At v equals to 30, that means at the velocity equals to 30, that positive velocity at the velocity equals to 30. Putting it over there, I have my d squared p all over dv equals to 3600 divided by 30 raised to power 3. 30 raised to power 3. That will 30 raised to power 3 will give me 27000. Then divide 3600 divided by 2700 will give me it will give me 0.133. That means my d squared p all over dv is equals to 0.133. What does it imply? It implies that this man is greater. That implies that d squared p all over dv is what? Greater than 0. This value is not greater than 0, is greater than 0. 0.133 is greater than 0. That means d squared p, second derivative of p in respect to v is greater than 0. And what does it mean? When it is greater than 0, that means that this value, velocity at 30, is minimum velocity of the engine. That implies, this what? Implies 30 velocity at 30 is minimum what? Velocity of the engine, or the least velocity, the least speed of the engine. Again, let us take the second. if I have again that my d squared p all over dv is equals to 3600 v all raised to power 3 at v equals to minus 3 minus 30 at v equals to minus 30. Now substituting the value, I have my d squared p all over dv equals to 3600 all over minus 30 all raised to power what? 3. That gives me 3600 all over minus 27000, and that will give me minus 0.133. That implies that my d squared p all over dv is equals to minus 0.133, and this implies that d squared p all over dv is less than minus 0. Is less than what? Is less than 0. This means that this implies that d squared p over v is less than 0. That implies that it's less than 0. This minus 0.133 is less than 0. That means it's less than 0. So when I said that implies, what does it mean? That implies that at this velocity, that implies velocity at that point, velocity at minus 30 is what? Maximum. Is the maximum velocity of the engine. Is the maximum velocity of the engine. That's the maximum velocity of the engine. So, but what we are asked is the minimum velocity of the engine, which we have done at v equals to 30. The value become what? Minimum. So the minimum velocity of the engine is a what? 30 meter per second. That's 30 meter per second. At 30 meter per second, the engine of this engine is running at minimum velocity. It's running at minimum. But at minus 30 per second, the engine is running at the maximum velocity or speed. Is working at the maximum. But at this 30, it's working at least speed. It's working at the least speed. So our answer is what? 30 meter per second. And that's what we have for you today. Thank you for subscribing to this channel. Thank you for helping me to grow this channel. Thank you for sharing this channel and commenting. See you in the next video.